In this video, we want to calculate the shortest distance between two nodes, and we'll look at finding the shortest path in the next video. So first, we should create our distances hash table. We want to set the distance to all nodes except the starting node to the maximum integer. So we create a map of node to integer, call it distances, and set it to a new hash map. Now for every node in this graph, we need to add an entry in this hash table. So for var node in nodes.values, in each iteration, we call distances.put, we pass the node and integer.maxValue as the arguments. Now we should set the distance of the starting node to itself to 0. So after our for loop, we call distances.replace. Here we need a reference to the starting node. So we call node.get and pass from. This will return our node object, and then we'll pass 0 as the value. We're done with this. Next, we should create a set for keeping track of the visited nodes. So a set of node, we call it visited, and set it to a new hash set. Now to kick things off, we should add our starting node to our queue. So queue.add. Look, here we should pass a node entry object because every object in this queue is a node entry object, okay? So let's pass a new node entry. Now here we need a node object. That is our starting node. We already got that object from our nodes hash table. So let's reuse this. I'm going to extract this into a variable called from node. And then we can reuse this in both these places. Now, as the second argument to the constructor of node entry, we should pass the priority. What is the priority of the starting node? We can pass 0. It doesn't really matter because this is the only item in our queue, okay? Now, as long as the queue is not empty, we're going to repeat our algorithm. So while the queue is not empty, in every iteration, we want to remove one item from the queue, and that is the node we're going to visit. So queue.remove. This will return a node entry object, but we want to get the node. So we access the node field and store the result over here. Next, we should add this node to the list of visited nodes. So visited.add current. Pretty straightforward. So here we are doing a breadth first traversal. We got a node from the queue. Now we should look at all its unvisited neighbors, exactly like what we had in the breadth first traversal algorithm. So here we need a for loop to look at all the neighbors of this node. For var edge and current.get edges. Now if we have visited the target of this edge, we should move on to the next iteration. So if visited contains edge.to, that is the neighboring node, then we're going to continue. Otherwise, we should calculate a new distance. That is super easy. We set new distance. Now we need to go to our distances table and get the distance to the current node. So distances.get current. Once we have that, then we add the weight of the edge to the result. So edge.weight. So let's say currently we are in the middle of our graph, and it takes 5 miles to get to the current node from the starting node. Now to calculate the distance to the current neighbor, we should know the distance from the starting point to the current point plus the weight of this edge, okay? So now we have a new distance. We should compare this with what we have currently recorded in our distances table. So if the new distance is smaller than what we have currently recorded, that is distances.get edge.to. So edge.to is our neighbor. If the new distance that we have is smaller than what we have, then we should update our table. So we call distances.replace. What we have for edge.to, or the neighboring node, we want to replace this with the new distance. Now that we have a new distance, we should push this neighbor to our queue. So queue.add, we give it a new node entry and pass edge.to, as well as the new distance as the priority. So if the new distance is shorter, this entry is going to be moved to the beginning of our priority queue. Okay? Then in the next iteration, we'll remove one more item from the queue and repeat all these steps as long as the queue is not empty. When our queue becomes empty, our distances table is ready, so we can return the shortest distance to the target node. Distances.get nodes.get to. As simple as that.